is you have to have a ruler and you have to have graph paper. Those are two musts with tip to tail. Okay, without graph paper and a ruler, you can't do tip to tail. So the first thing you have to ask yourself is, are my vectors parallel or perpendicular? So if I had 3 newtons to the right and 4 newtons to the left, are those perpendicular or parallel? They're parallel, right? Because they're in the same plane, like railroad tracks. So in this case, I just take 4 minus 3 is 1 newton, and it's in the direction of the bigger one. So in this case, it's 1 newton to the left. But it's when you have perpendicular ones that you need to do tip to tail, okay? So let's say we have 3 newtons up and 4 newtons right. Now those are parallel. Those are perpendicular. Perpendicular means they're like that, like an upside down T, okay, or a right side up T. So the first thing you're going to do is you're going to pick a point to start, and I don't care where you pick a point, just pick one. I like to circle it because that reminds me that's where I started. Now the most important thing is tip to tail is that your accuracy of measurement. So I know I want 3 newtons up. In my case, I'm going to let 1 newton be 1 centimeter. So I'm going to go 3 centimeters exactly up. Now I'm going to cross that one out lightly just so I can remind myself that I've already done that one, right? Does that make sense? Okay, so now this is the tip of the arrow, this is the tail of the arrow. I'm going to put the tail of the 4 on the tip of the 3. A lot of people want to go back to the starting point. You don't. You're done with that starting point for right now. I'm going to start from right here. And again, 1 centimeter is 1 newton. So I'm going to go 4. Let me make sure my line is perfectly straight. I'm going to go 4 centimeters to the right because that's what it showed me. I'm going to cross that one off. Now I'm done with this one, right? So I circle this because that's the end. Does that make sense so far? Okay, I put my pen on where I started, and I'm going to draw a line from where I started to where I ended. In this case, my line was drawn in that direction. So that's the first thing I write is the direction that I drew. Now I have to figure out the magnitude. So I'm actually going to measure this line and see how long it is. And it looks to me like it's 5 centimeters, which means my resultant, or the thing that I get when I put those two together, is 5 newtons. Okay? Let's do another one. This one's going to have, let me move this over a little, 6 newtons to the right, 4 newtons down, and 2 newtons to the left. Okay? It doesn't matter what order you go in. You can start with any of these, and you can put them together in any order. That doesn't matter. The only thing that matters right now is that I pick a starting point, and I'm going to pick right here. And I'm going to circle it. Now when I pick my point, I kind of look, did I leave myself enough room to go 6? Did I leave myself enough room to go 4? Do you know what I mean? Otherwise I have to tape another piece of graph paper on here, and that's kind of a pain. So that's my starting point. I'm going to go 6 newtons to the right. So from right here, 6 newtons to the right. Ooh, I didn't leave myself too much room, but I left enough room. And did you notice how I always mark where I end first? Did you ever notice I make that? Because that makes it a little easier for me to know how far I'm going to go. So now I've got my 6 newtons to the right. Now I'm going to go 4 newtons down. Again, I leave this alone. I don't mess with this point. I mess with this point right here. And I'm going to go 4 newtons down. And that looks to me like that's about 4. 4 newtons down. And now I have one more. I have 2 newtons to the left. And again, I go from where I just stopped. I don't go back and reuse anything. I go from where I stopped. So 2 newtons to the left. And again, in my scale, a newton is a centimeter. And I'm done. I've used all 3 of my numbers, so I circle where I ended. Now in order to get my resultant, I put my pen on where I started, and then I put my ruler in place. I always put my pen down first, because then to figure out the direction of the vector, all I need to do is say, what direction did my pen go? And in this case, my pen went that way, didn't it? So that's my direction. Now the magnitude, I'm actually going to measure, and it looks to me like it is just about 5.5 newtons, or 5.5 centimeters. 5.5 centimeters, 5.5 newtons. Does that make sense? Okay. Do you want to try some on your own now? You want to try a couple on your own? Do you have questions?
There was one where it's like there was 4 numbers, like 2 were the same.
Got it. Okay, let's do one of those. Let's do 6 newtons. Let me move this so you can see it. 6 newtons down, 2 newtons right, 4 newtons left, and let's say, do you want them to go, the next one to go up or down? What did the last one do? Do you remember? Was it up or down? It was up. Okay, and then let's just say 3 newtons up. Okay? And you can do tip to tail on this. I'll show you an easier way when we're done, but tip to tail is fine. We'll start right here. Put a circle around it. 6 newtons down. Again, a newton is a centimeter on my scale. So there you go, 6 newtons down. And then I like to cross it off just so I know I already took care of it. 2 newtons to the right. Again, a newton is a centimeter. Oops, you see how I'm off a little bit on that? Can you see that? So I'm going to redo that line because I didn't go really to the tip. And a little mistake like that would be a big mistake when I finished up. Okay, so my 2 newtons to the right. Now it says 4 newtons to the left, and I start here and go 4 to the left. And this is why I use graph paper. If you use graph paper, you'll know exactly if your line is straight or not. And you see how I went right back over that too? That's okay. So my 4 newtons, now 3 newtons up. Three newtons up, and I'm done. So I circle where I ended. Put my pen on where I started. Draw my line connecting where I started with where I ended. That's the direction my pen went. That's the direction my resultant vector goes. And now I just measure it. It's 1, 2, 3 point about 6 or 7. And that's my resultant. Now if when you do this you come back right to this point, that means your resultant is 0. If you're starting and you're ending at the same point, your resultant is 0. Now, you ready for me to show you an easier way to do this one? Okay, here's an easier way. I look at the 6 and the 3, and they are parallel vectors. Sorry, I did that wrong. 6 down, 3 up. Are those parallel? So when I put those together, what would I get? 6 down, 3 up. I'd get 3 down, right? Okay, now I look at these two. 2 newtons to the right, 4 newtons to the left. When I put those together, what do I get? I did that wrong. 2 newtons to the right, 4 newtons to the left. What do I get? 2 newtons to the left. So if I want, I can draw tip to tail with just those two, and I should get the same answer. Let's see. We'll pick a point. 3 newtons down. Again, a newton is a centimeter using my scale. A little bit less accurate when I use a marker because the marker has width, doesn't it? So I'm done with my 3. Now 2 newtons to the left. Okay, 2 newtons to the left. That's it. I'm going to put my pen here. I'm going to draw a line from where I started to where I ended. What direction did it go? That way, right? How big is it? That time I got about 3.6 newtons. Look at how close this one is to that one. So it's okay to put ones that are parallel together first if you want, or draw all 4 of them. It doesn't matter. Other questions? Who's ready for a concept quiz? Okay, let's take a concept quiz.